Hi everybody, so today we're going to be talking about Schwann cells, and before we start I just want to tell you something real quick. Schwann cells were named after Dr. Schwann, who was German, so that's actually pronounced Schwann cells. This actually sounds like a V, but because we're in America, we're going to use the W sound to call them Schwann cells. But let's go ahead and get started. So the first thing about Schwann cells, we're going to look at kind of what they do. So the thing about Schwann cells is basically they make myelin in the PNS. Now, if you recall, oligodendrocytes make myelin in the CNS. So these are kind of their counterparts in the PNS. The other thing about this is, just in case you forgot, myelin speeds up nerve impulses. So it makes them go faster, right? So it speeds up nerve impulses. Now, if you recall also when we talked about oligodendrocytes, we said oligodendrocytes are branched and they can hold on to a bunch of different nerves or even different segments of the same nerve. Schwann cells will only myelinate one segment of an axon, and then you'll need another Schwann cell and another Schwann cell. We'll draw it in just a minute. So Schwann cells only myelinate one segment of an axon. They're also going to play a role in unmyelinated axons, and I'll talk more about that later. But Schwann cells are also responsible for injury repair. And we're going to talk more about that in just a minute also. So let's go ahead and take a look at this, and I'm just going to move this real quick. And for the most part, I'm going to draw some cells now, and we'll talk about the Schwann cells, okay? Well, and we're going to talk about myelin. So here's my nerve cell, and there's my dendrites, okay? And then we're going to have my unmyelinated axon. And what's going to happen when an unmyelinated axon is when an impulse comes down, it has to travel along the whole axon. And we're going to call this continuous conduction. Okay, because it has to travel down the whole thing. Sodium and potassium gates have to open and close the whole way down. Now, if we look at one that's myelinated, right, so this will be my myelinated. Now what's going to happen is I am going to still have my dendrites coming out from here, right? And now this is going to be my myelin right here. So if we look here, this is all my myelin, okay, and then that's my synaptic knob right there. So this is going to be myelin. And then if you notice between the myelin, we have actually these little openings that we call nodes, and we're going to call these nodes of Ranvier. And then what's going to happen is my sodium-potassium gates are going to open up just in these areas. So when they look at this, it looks almost as if the impulse is skipping over this to get down that axon, okay? So, and this is, again, in a myelinated axon. All right, now, this is what I'm going to do. We're going to take a cross-section of this axon here, and we're going to take a cross-section of this axon here, and let's take a look at these real quick. So if I go over here, right? And what I'm doing here is I'm going to take this, and actually let's start down here. We're going to take this, I'm going to pull this out, and I'm going to turn it like this, okay? So we're looking at the axon going this way, and now we're going to turn and just go, and you're looking straight down at the axon now. So here's what's going to happen. Let's talk about how these are formed. So here's my axon, right? This is my axon. And then I'm going to have my nucleus. So let's just say this is the nucleus of my Schwann cell, right? And what's going to happen is the Schwann cell is going to actually start to wrap around this axon. This is how we're going to form myelin, right? And if you recall, this is going to be, my cytoplasm is going to be in here. And then, because this is the cell membrane, it's a lipid bilayer. There's one layer, there's this a lipid bilayer, and there's my lipid bilayer. Right? And this is going to continue to do this. And then eventually what's going to happen is it's going to squeeze and it's going to force the cytoplasm out from here. And when it does, this is going to become a lot tighter. So now what's going to happen when we're done is my axon is going to look, my cell is going to look something like this. There's my axon. And then because we got rid of that cytoplasm, this is actually going to be wrapped around it. Let me draw my nucleus real fast. And there's the nucleus. And what's going to happen is it's going to be very tight around here. And basically the only place I will find cytoplasm after this is by that nucleus there. Okay, and then I'm going to have some cytoplasm here. So again, this is going to be my nucleus. And this now is my myelin surrounding that axon. Okay, so that's how we form the myelin. So let's go ahead and take a look at an unmyelinated axon, because the Schwann cell is still going to play a role in this. Okay, so what's going to happen here is I'm going to draw my Schwann cell, and it's going to be like this, right? And then what's going to happen is surrounding this, I'm going to have my neurolemma, and my neurolemma is going to have, the axons are actually going to indent in here into the Schwann cell, okay? So I'm going to have these indentations. This is the neurolemma right here. And then I'm going to have these indentations here. And in those indentations, I am going to have axons that are basically in the cytoplasm here. So you can see when it's unmyelinated, the Schwann cell actually holds many axons. Here, it just wraps around one axon. So this is going to be myelinated. All right, and this is going to be unmyelinated. Okay, so now, that's how that's going to look, right? Oh, and by the way, and then inside of here will be my cytoplasm, or would be the cytoplasm, would be inside of there, okay? So that's the role that Schwann cells play when it's an unmyelinated axon, right? And of course, this is again looking straight at you there. But you can see this is going to be holding many different axons around here. Here, it's just the myelin surrounds one in one area, and then you have another area, then another area, another area. Okay, so now let's take a look at injury repair. So I'm going to move this right over here. And let's take a look. So once again, let's draw, of course, this is going to be on a myelinated axon. So here's my dendrites again. And here's my axon. And here's my myelin, right? So let's say we get damage here. Well, first, before we go there, if we get damage to right here, the cell body or the soma, if you get damage here, this is not going to regenerate and the nerve is dead and it's dead forever. But let's say we get damage on the axon, right? So we have this damage here. And from the damage now, we start to get particles here. So what's going to happen now is I am going to have white blood cells are going to come and they're going to clean up this debris here. At the same time, remember, this is my myelin, and my myelin is made by Schwann cells. So in the same time, what's going to happen is this is going to start producing more Schwann cells. And these Schwann cells now are going to release growth factors and different substances that are going to help that axon to start growing again. So now my axon starts to grow again. Right, here's my axon growing. And then, of course, it's going to repair itself. Right? And then what's going to happen is these Schwann cells, they're going to start wrapping around the axon and repairing it. Okay? And then it's going to get all cleaned up, and my nerve will have been repaired. Okay? So that's the role that they play in nerve injury, is that they're going to help repair it by growing back the axon and making more myelin. So that's it for Schwann cells. If you enjoyed the video, please hit the like and subscribe button, and we will catch you next time. Thanks for watching.